Hey guys, welcome. Just connecting up. Gonna see if we're live or not. Connecting, getting permission and doing everything. I am just gonna do a quick Instagram post. Hey guys, welcome to live stream number 4. Come join me. I am streaming on YouTube, Twitch, and Mixer, and Periscope all at the same time. So come join me. And we are live now. You can see the camera in the background. Yep. Alright, talk to you guys soon. Come join me. I am streaming on YouTube, Twitch, and Mixer, and Periscope all at the same time. So come join me. And we are live now. You can see the camera in the background. Yep. Alright, talk to you guys soon. Hey. Alright. Sorry about that, guys. Let's see. Alright, looks like everything's online. We are counting down from 3 minutes. I'm going to do that video over again because I sound like an idiot. Hey guys, Cerebral Dad is live talking about robots. Come join me. I'll talk to you. She can hear me. Guys, Cerebral Dad is live talking about robots. Come join me. I'll talk to you. She can hear me. Hey guys, Cerebral Dad is live talking about. Sorry guys, you had to hear that, but I'm new to this social media crap. See if anybody is on the chat. We got one person. Nice. Okay.
Are you guys seeing what I'm seeing right now?
No, Tucker. No, we're not seeing what you're seeing. Alright. Alright, we got a little over a minute. I want to say, hey guys, we're going to be talking about ROS today. ROS is the robot operating...
Yes.
Alright. I should unplug her microphone. Alright, we got about 40 seconds. Hey Rob, how's it going? Michael? Ceramic Johnson. Alright, welcome, thank you. Looks like we're up on Twitch. Hey guys, what's going on over there? Periscope, what's happening? Nobody on Mixer. Maybe I shouldn't stream there, just waste bandwidth. Hey guys, there's a few guys on YouTube. Alright, let's get started. Hey guys, welcome to another live stream. This is number 4, and we're going to be talking about ROS, the Robotic Operating System for robots and the like. So what exactly is ROS and why we're using it? Thanks again for joining me. So let's dive right into it. I don't want to take too much time today because I have to pack for a trip. So, okay. So, the robotic...
Yes.
Working on voice recognition, so excuse me. I should unplug her microphone.
Sorry, I don't know that.
Alright, yeah, alright. It's the Alexa API. Okay. So why do we use ROS? First of all, it's free. There's a huge community that uses it. There's a ton of languages that it can support, including C, Python, Lisp, I think it is. I'm not quite familiar with that. There's library integration, so you can use things like OpenCV, open source computer vision, point cloud library, which the Connect uses. I don't know if you follow me on Instagram, but I just posted a picture. I got the Connect working on the robot. So it also supports simulation integration, so it uses things like Gazebo, Weebox, and VREP to allow you to test your code and multiple things. So, and speaking of code testing, it allows you to actually do something called ROS test, and it checks your code for errors, consistency, and it also lets you know if it's scalable. One of the major features about ROS is that it is scalable. You can write very, very, very complicated programs with very little overhead. That's why you see people using ROS on Raspberry Pis and even Arduinos. So it's very scalable, and there's very little overhead. All the way up to the 2 terabyte, I believe, hard drives in some of the MIT robots, all dedicated towards ROS. It's very customizable. There's packages all over the place in the community, people who've done things that you might want to do. You can download things for free and try them out on your robot and your simulation to see if they work for you. What ROS is it's a pub sub type system. It allows you to publish on topics using messages, sort of like a really complicated chat system. That's exactly what it is, actually. It opens a series of sockets. You talk to a mainframe or a core, which we call home, that publishes messages and topics. And if any other nodes are subscribed to it, then then they can perform their actions. We'll go into a little bit of one of the nodes that I've been playing with the image recognition, and we'll see exactly how that works. So if you're not a fan of programming,
Yes.
if you're not a fan of programming, then you're going to need to now watch.
I don't know that.
Let me just unplug her microphone. There we go. Now she can't hear me. Alright. So where should we start? Alright, let me just show you the file system on the robot. Here I am. I'm signed into the robot here, and I want to show you the file system. So ROS has it's built assuming that you're going to be using a Linux type platform. There's libraries and packages for other types of programs, platforms like I said, the Arduino and Teensy and other things like that. But mainly, at its heart, it's a Linux-based framework. So what you would do is you would build a node that publishes to a topic with a specific message. So you got a node, a topic, and a message. So let me just show you. So I could CD into a regular folder, like I go to development and all that, but ROS makes it a lot easier. You can go ROS CD and the name of the package that you've been working on. So I called mine robot main, and it takes you right there. So I can go to the launch file. So launch files are basically XML files that allow you to launch multiple nodes at once, and this is what mine looks like. I'm gonna use Nano, I think, to show you, because it prints it out a little bit better. I think I called it sensors, yeah. And here it is. So basically, the reason the robot was interrupting us so much is for the first couple nodes here. I have Pocket Sphinx running, which is a voice recognition software that's written in Python. So you'll see that I have both Python and C++ packages in here, and you can write it in any of those two languages and use them simultaneously. So you can't see my mouse. No, you can't see my mouse. So right here is something called Serial Node. Serial Node allows me to, let's see if we can see this here. It allows me to connect to the Arduino right here, and the Arduino can actually publish to topics and use messages as well. And that's the whole crux of how I'm going to get this robot working. Let me put this down here so you can see me and turn that off real quick. Okay, so that is the basic crux of how I'm going to get different sensors like the ultrasonic sensor and other things to communicate with ROS using this bridge or serial node. So it just talks to, there we go, to ROS using that USB port at a certain baud rate. So this is Turtlebot. Turtlebot Teleop is a package that's already been written for a specific robot, and what it does is it has a nice keyboard interface. And when I was trying to get the motors to work through ROS, which is a whole nother story, in itself. There's a whole lot of math that I need to figure out. I need to buy rotary encoders for the wheels and stuff like that, so I can figure out when the wheels are moving. But I threw this in here because I was trying to move the robot remotely from the computer, and I haven't gotten that to work yet. This is another speech recognition. There's an answer node that I made that's an action. So there's nodes, topics, services, actions, and I think there's something else called a bag, which we'll get into when we get into SLAM, which is the dynamic mapping that allows the navigation of the robot autonomously. So we'll do that later. Not in this episode, but in another. The big thing here is the ROS, this open NI library, which connects to the Microsoft Connect. So I don't have much going on here. It's just listening to or listening for my voice, which I unplug the microphone, and it activates the Connect. So it's not doing much. This is just something that I've been fooling around with. But let's go ahead and launch that. We're going to get an error, and then we're going to fix it. I'm going to tell you why. So you just go ROS launch. Which one? ROS launch. ROS launch. I think you give it the name of the package, and I'm going to call it the sensor. And we launch that. It goes through its thing. We get an error. Let's go see why we get that error. So we have multiple things called Pocket Sphinx Recognizer. Let's see where we are with that. Actually, you know what I'm going to do? I am going to get rid of that because we're not going to use that right now. What is it talking about? 2 pocket sphinxes. Let's see. Pocket Sphinx Recognizer. Please check all node name attributes to make sure they're unique. Blah, blah, blah. I don't care about that. Alright, so I'm going to do this. Pocket Sphinx Recognizer, period. I don't have it in here twice, do I? No. So I'm not gonna actually use it. So let's do this. What I'm doing now is I'm commenting it out. Oops. Dude, I've been doing this a long time. Okay. So let's do this. And let's try running that again. Why are there multiple nodes? Is it running already? Let's see. Okay. It's not running. Okay. Why is it doing that? What I'm gonna do here, just get rid of it. Oh, hey, there's Rob and Penny. Hey guys, what's going on? Sorry, I'm deep into this trying to figure out why this is doing what it's doing, so bear with me here. I was fiddling around with it. Alright. Let's see. Alrighty then. What happened here? Alright, we're going to do something else. I'm going to go this way and edit it with an editor because this is annoying. Let me just show you what I'm looking at here. The robot was funny. Yeah, I know. I'm sorry. Yeah, I disabled it. Alright. Let's see here. I am going to just go here. And I am in document development, ROS, workspace, SRC, launch, yeah. Yeah, the robot interrupting. I am just going to take, let me just make a backup copy of this. Alright. And I'm just going to take all of this. I want the serial stuff. Take all that out. Don't need the keyboard stuff. Don't need that. We'll stay with that. Okay. Okay. Save. Close. Let's go back over here. Control exit. And over here. Serial node. What the? Alright. We are going to do this. Open. Yes. Okay. Let's see. Okay, so what this is going to do, it's going to try to connect to the Connect, but it's not going to be able to. And it's waiting for the devices. So let me go and turn on the robot real quick. Let's see. I got a question. What operating system? It is on Linux, Ubuntu 16.04. I program everything. I've been reading up on programming. Sure is a lot to know. Yes, it is. So this is actually programmed in 3 different languages. So, I don't know. Let me just turn this on real quick. Okay, there's that. I'm going to put something in the way here. Okay. Oops. That's what I didn't want to happen. Okay. What I can do, stick this here. get it something to recognize. We'll see if it can see this or not. This should be right in its way, so we're good. Okay. Okay, and as you can see, it got the IR camera, which is the Kinect. And what we're going to do is go back over to the VNC here. And I'm going to close this real quick. And what I'm going to do is from here, I can go in and do like a 2D sensor thing. What I want to do is say, we can go back over here. We could just look at a few things in ROS real quick. So, here's another tab. Uh-oh, can you see that? No. How can I do this? So you can see this. This is going to be pretty interesting. Bear with me here. I gotta make sure you can see all of the windows here. And I am going to put this here. Okay. I'm going to do display capture and this. So can you see that okay? Don't want it to be too small for you guys. Okay. Alright, cool. Alright, so now I have to let's see. And we can say ROS topic list. And this is everything that the robot is spitting out. Speaking of the robot, let me show you that real quick. Stick the robot up here. You can see the robot. I have the Kinect here. All right, good. So now you can see this is what the Kinect is. There's so many camera topics that it's posting on. So what we're interested is the camera RGB image color right here. So what we're going to do is here we're going to run something actually on the robot that we can see the image from the I wrote a package that finds a 2D object, or I modified one actually. And let me just do VS Code, find object, and then we have to give it an image, and it's going to be the topic that we said, and that is going to be, no, I forgot already. What is it? Camera RGB image color. So camera RGB image, I think it's color. Image underscore color, yep. And let's see what that brings up. Maybe I spelled it wrong. Find object 2D, find object 2D. Image, got that. spell it wrong? Find object 2D, find, oh, yes I did. Need the 2D in here. Okay, so that should bring up the image of the mug right there. And you can see that it is trying to recognize different cue points, changes in contrast, and so it definitely knows that there is a mug there, but it doesn't know what it is. So we're going to help it along a little bit. And then we're going to add object from scene, right? So now what we're going to do is we're going to track this object right here. I don't want it too big. Okay. Take picture. Okay. Select region. I'm going to do this right here. I'm going to say next. And it's going to say, oh, well, what is that? It has 17 features. It's out of focus a little bit, but we're going to see if it can track it now. Look at that. It knows what that is. And if I go into the image, I can move it around. And because it wasn't so complicated before, there we go. It's very, 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 I didn't pick a very high contrast thing, but you can see how the image tracker works. And just imagine if that was me or my face. If I walked into the room, it would track me by, yeah, it's a flight test mug. So, that is a flight test mug. I should have picked something else, but I just wanted you to get the idea. So now, if we look at the topic that it's spitting out, it says, got 82 descriptors, we got a whole bunch of stuff going on, right? Alright, that'll give you epilepsy. Hold on one second. So if we took that picture and we hit next and we hit end, and we did all that, so now what we can do is we can name it, I think, somehow. I took some notes here. Yeah, so it can find that. Let's see if we can track something else. Hold on one second. Let's find something else. What's something that is pretty distinctive? Let's do a red cup here. Do a red cup. Let's see if we can follow it. And what we're going to do now we can go like this. There's not many features, but I want to see if it can track it. Of the red cup. Let's see if it can track it. Get objects, file. Okay, so I'm going to do this. I'm going to add an object. There's a take picture button. Cool. Let's see. Now you can right click the left hand. Oh, I have to add a pit. Add it over here. Okay, so we're gonna take a picture. It's black and white, and the reason it's black and white, I was hoping it would be in color. Okay, next, it has one feature registration. So let's see if that feature ever gets picked up. Now, I'm doing a pretty bad job of let's see if we can find it. So you can see all the registration points on me. Like I can detect if it's human or not. That's pretty cool. Alright. So basically great mud glove ours, yep. So to track a 3D object, it would need a scanned on all sides. What you would do for a 3D object, you would need a 3D model of it. So you would make something in CAD or something like that. And let's see here. Yeah, so 3D objects is something that's used in tracking when you're doing like self-driving cars or whatnot. So let me see if I can visualize like the 3D cloud map for that. Let's see. 3D objects are pretty complicated. Let's see. Where's my notes on 3D objects? Yeah, so another thing that you need CAD for is like if you wanted to use a simulator as opposed to me doing everything in real life. You can use a simulator and you can make a CAD drawing of your robot and add physics to the robot, and it would be just like you're controlling it in real life. So let's see. I'm gonna close this out real quick. Yeah, why not? Save the added objects. Let's go development ROS. Save them here in the workspace. .2D objects. Can I rename it? Whatever. New folder. I'll change it later. Alright, cool. So. Oh, I know how I can do it. Let's see. What is it called? RViz. Let's do this. Oh, can't show it. Oh, it takes up too much memory. Let's see. Any other questions? Like, I know I'm all over the place, like I always am, but I know what I'm gonna do. Let's see. Which one do I want? Depth. I want the depth. Image. Depth image raw. Camera depth image raw. So what I want to do is I'm going to do ROS topic echo. I keep forgetting what it's called. Okay. Camera depth image. So these are all the points in the point cloud. What programming language would you recommend to start with? Depends on what you want to do, really. Someone new to coding, I would start in Python or JavaScript. That would be my guess. Let me just do a little research real quick. The best thing about this ROS is it's a highly supported framework. So like I could say ROS connect view depth cloud, and this is really cool. I forget what. Let's see. So let's see if we can get this going. Oh, okay. So what we can do here is ROS run R. I had it right. Let's see. Got that. Let's open this in a new tab. Maybe I don't have it installed anymore. I think I uninstalled it to make it go a little bit quicker when I was doing other things. See, so if you want to know anything else about it, you go to wiki.ros.org and you can basically search anything. I don't think I can do it using a virtual server. Let's go here. So basically I would be able to see something in 3D point clouds, which is really cool. And this is how, one of the ways the robot will be able to detect distance. So anything highly white would be far away, and using pixel math you can really determine how far away it is. Let's do this. Let's do this command. Let's see if it'll show us. Oh, come on. ROS run image view. Okay. That's not what I wanted. We're always running image view, camera depth disparity. Okay. Let's see what this one looks like. Camera depth disparity. Could not find executable up. Oh, because I spelled it wrong, dummy. Camera depth. Oh. Here we go. This is pretty cool. So now, I am now an image cloud. And this is very close, further, about the same distance, closer, further away. So this is how you would gather distance. See, this purple is this furthest away. So you can assign a distance to these things using a different sensor, and you can compare the two and keep them both very accurate. Okay? So that's pretty cool. Let's take a picture of that, because that's really cool. Oh well, there's nothing cool in the thing. Alright, so there's that. I said close. Alright. Nice. So there's that, and let's see what else we can do. Disparity view, registered disparity. So that's a little bit more. Oh, points. Depth registered points. Okay. So we can do what is it? Camera depth registered points. Okay. Depth registered points. Oh my goodness. I spelled it wrong. Again. Too much pressure. You ever do any coding for extra cache? Of course I do. Yeah. So it does help it see the 3D object better. And this is good. Is it up? Registered disparity. Okay. So, let me just make sure I got the right node. Camera depth registered points. Okay. Maybe that's only on our viz thing. Depth registered points. Alright, whatever. It's not working. But yeah, I do coding for cache all the time, like websites, mobile applications, and things like that. I do that. So let's see what else we can do here. That is pretty cool. Image view. Oh. So, and you can also just do Like if you just want to use it as a webcam, you do image view. And these are all topics that other things would subscribe to and be able to get the information from. Dang it. Get the information from. So you do depth or camera, RGB, image, raw, something like that. And that's just, you know, the basic using the Kinect as a webcam. So we can do that. Image camera depth image. We could do that. Depth. So this is pretty cool. This is without the color. You can just see the closer you get, you are black. The further away you are, the whiter it gets. So it's a great way for us humans to visualize what the robot is seeing. But again, this is actually not ROS run. This is actually what it's seeing. So it can process that at about 9,000 times per second or so. If you funny saying rocket scientists. My father-in-law was telling us coding for some website or forums will help make extra cash. He is a rocket scientist. Oh, nice. Well, I use Linux. Is it better for programming? It's just very lightweight, and the computer inside the robot is, very small. It has to be a small form factor, so it's only got like 500 gig hard drive, 8 gigs of RAM, and things like that. So I'm just gonna stop that because that's making me dizzy. And so there's a lot of things that you can do. So just a general overview of something that the robot would be doing is, I wanted to see, I think I want to show you, let's try to do it here. TF. Yeah, I think it's TF. Okay. ROS topic echo TF. I don't think it's doing anything. It's not doing anything at the moment because S9 Linux is on the robot. Oh, so Linux is on the robot. Okay, yeah, Linux is definitely on the robot. But you can use any computer that you want to go into it. So what I do is I'll open this here. And I can just have an SSH connection and do all my coding through here. I don't know why this is taking so long. Let's option force quit. So that's just one thing. I wanted to show you something interesting with the so there's an Arduino on the robot, and it can control, like you saw in the other live stream, it can can control, I'm just going to close this. It can control all of the sensors and read all of the sensors, and what it's going to do is going to act as like a little node server, not JavaScript node, but a node server in ROS, where it can gather all the information from the sensors and publish it to these topics that you see right here, and then other things inside the robot can subscribe to that. And then use the raw information, like the raw image data, like a sensor, like this is the next thing that I was going to hook up to the robot, like a sensor like this. This is an ultrasonic sensor that detects distance, and this is something that I would want for very finite, very close, accurate distance detection to counteract the Kinect's distance sensing. The Kinect can also do like a laser scan, so imagine like a laser level, just scanning the room for just different objects in its way. So that's something that we're going to be looking at too. But first things first, I need to buy 2 rotary encoders. So what they are is, I'm going to go here, I'm going to show you. They're basically knobs that you put on the end of a motor to tell it if it's spinning forward or if it's spinning backward and how fast it's doing that. Because imagine if you're trying to accurately navigate a robot and one wheel is spinning and one wheel is gaining traction, it's going to be turning in a off center. But the robot doesn't know that. It just knows that it's spinning both wheels at, or it's sending the command to spin both wheels evenly. It doesn't know that it's off center unless you have like an IMU, which is like an inertial measurement unit or something like that, that can tell you that it's going off course. But you need those rotary encoders for the feedback of what the motors are actually doing, and so that it can correct itself and stay on course. It doesn't use the camera. Yeah, all the numbers scrolling on the screen is the image and the point. The point, imagine thousands of points make up an image, like pixels. Each one has a value, and that is called a point cloud. And that's something that the robot uses to detect different image values and distances. So the way it does that, it actually projects a radiation into the room and see how that, it's not like radiation like cancer causing radiation, it's the same radiation that your cell phone gives off, but it projects that into the room, and whatever it bounces off of at a different rate, that's how it can tell how far away things are. So it's pretty cool. Pretty cool. And as you can see here, I didn't even scratch the surface of anything that the camera can do. I mean, we just looked at an image and some point clouds. There's millions and millions, well, there's about 100 things that the camera can do. And I'm going to have, all in all, I think I'm going to have about 25 different sensors on the robot, and they're all going to be communicating using this ROS framework of publishing and subscribing to information, and then all aspects of the robot can talk to one another. And then imagine if ROS has something called a ROS core, and you can place that core, and that's the thing that's listening to all these topics. Imagine putting that on the cloud somewhere. You can publish to that, as long as you have an internet connection, anything around the world can publish to that. Imagine having 75 robots, or like a company like Amazon that has hundreds of robots talking to one another in real time at any given time, doing their packaging and sorting and picking and shipping and all that stuff. So it's this is what I'm calling Skynet preschool. So I'm basically just trying to harness the ability of a few sensors on a robot just to learn robotics. That's all the time that I have for today, but I really hope you enjoyed it. My name is Keith, and it is August 17th, 2018. I hope you enjoyed. If you did, please give a thumbs up, subscribe, share it with your friends. Links in the description below for t-shirts. I also have these really cool magnets and stickers, so if you feel the urge to support the channel, I'm very new to this. I'm going to be publishing more edited videos on sensors that I make for the robot. I'm going to do a battery monitoring sensor that'll publish on this ROS system, and I'll do a more edited version of that and show you how I'm going to integrate it into the operating system and the packages that I make for that. So that should be very interesting if you're interested at all in any of this. Yeah, thanks for thanks for coming out, guys. Like I said, I'm going to be making a few more t-shirts. I have a few more ideas in line. I just need more subscribers so that I can start monetizing some of these videos and start making it a little bit more worthwhile. But until then, there's a PayPal link, there's my Patreon link, there's links for merchandise in the description. So if you like it, please again, thank you, and support the channel, and I'll see you guys next time. See you next Friday, and I hope to have a couple videos out before then. But thank you very much for coming out. Thank you, Peggy, and all the other guys on Twitch and well, Mixer didn't have anybody, but YouTube. Thank you very much. I'll try to get back to you guys as soon as I can. If you guys want to stick around, I'll stay in the chat and talk with you guys. So I'll talk to you guys soon, and thank you very much. See you next time.